Hello and good afternoon. I wanted to share a video on looking at SELinux, particularly in relationship to Cobbler. Um, some of the diagnostics I've had to do here recently have dealt with SELinux and trying to figure out whether or not SELinux was getting involved in errors that I was experiencing with Cobbler. So let's take a look at things. First of all, what is SELinux? SELinux is a security enhancement to Linux, which allows for the control of access at a fine degree with mandatory access controls. Get this browser over here. This is the Wikipedia page. And it's available on all Red Hat systems, and it is available on certain other systems as well as an add-on. Now there is another package for security out there, but it's not as fine-grained. So SELinux allows you to, excuse me, allows you to control down to the point of whether or not a given process can access a given file and whether it can read it or write it or do other things to it. And it's another layer on top of the discretionary access controls of the read, write, execute, read, write, execute, read, write, execute permissions that you're used to on any Linux or Unix file. It is an enhanced attribute that is stored in the operating system's uh, space in the file system. So, and as it says here, it was invented by the National Security Agency, the NSA. Given that it was developed by the NSA on some of the key concepts, the idea that the concepts were developed by the men in black that protect our national security, that says something about it. So, allow me to first demonstrate how to determine whether or not SELinux is causing a problem for you. I closed the window too soon. The bug 2183 on Cobbler talks about when you start Cobbler, it has an issue and it fails to start. And it was tracked down to the varlib Cobbler WebSS file. Now, the way to tell whether or not it is a SELinux issue or not is to take a look. Let me go ahead and just drag this over to the other window. Is to take a look and see whether or not the process logs errors in a log file under var log audit called audit.log. Now what I've done is I've set up a file with the permissions that it had when we exhibited the problem. And we can take a look at those by the command ls-laz and then we'll add our file name, varlib cobbler web.ss. We can see here that it is owned by Apache and root with a file context, and that's the SELinux context applied to the file of system user object R cobbler varlib t and an S0 fine grain. Most of you'll see these end in S0. If you're seeing more than S0, you've likely got what's called mandatory access control enabled. But here it's like this, and we'll do a systemctl start cobbler d. Oh, I have to authenticate. Oops. We'll do it over here where we've actually got a root window on the system. Systemctl start cobbler d. Now if we take a look, we can see that it is a dead process. And let's go ahead and drag this window wider. Here we see that it's dealing with varlib cobbler webss, and it gets error no 13 permission denied on that file. Now notice up here we have no message that says, hey, we've got a SELinux issue. So literally all we have to do in this case is change the ownership back to root, which is what it was created as, and then systemctl start cobbler d, and then systemct type what I want, not what I tell you to type. Status, and notice here, while we're getting some warnings, let's take a look at those as well. That's indicating that there's something in the data. So we've got that, and it's up and running. Now, let's take a look at secondary.conf. Does not exist. So if I do a sync, notice here we're getting denieds. This is an SELinux problem. We can see here that if we take a look at one of these, we've got a timestamp, an indicator that it's a context denied, the DAC override. It's trying to set a discretionary access control. Notice it's a very fine, I can't even set permissions on it. And process ID, the COM capability, so on and so forth. And that's how you can tell what it is. And if we take a closer look, here we're getting a denied create for Cobbler D, trying to create secondary.conf. It's denied write, and you can proceed to go through and see everything that it's trying to do. And at this point, it's probably a good point to say, okay, well, how do we do that? Drag this back over. I've got a pair of monitors that for some reason I can't drag across the middle monitor. Over here in the Red Hat documentation, since Red Hat is the basis for, Red Hat Enterprise is the basis for Fedora and CentOS and Rocky Linux and Scientific Linux and all the others. It's a good spot to go for documentation, and I'll put links down below. Here we are with talking about the benefits of SELinux, where we have the user role, that's the R, the type, that's the T, and the security level, the S0. And it's extremely fine-grained, as we've seen, but it should be noted that it's part of an overall security strategy and not a one-stop-gets-all. It goes through and it says, for example, that the HTTP server, if it's compromised, the user can't read files such as the password file or home directories or things like that unless there's been a policy rule that was added to allow that access. So it doesn't replace antiviruses, it doesn't replace passwords, firewalls, any of the other things. And think of it as just another layer on a big old jawbreaker, one of those solid jawbreakers that you had as a kid that you'd have to suck on it for a day before you got down to something that you could break it with your teeth. And that's what SELinux is. And it's another reason why when I see someone talking about turning off SELinux to disable it, as the terminology goes, or to make a process permissive, it's one reason why I cringe when I see instructions like that, when you're far better off developing the the policies for your process. I've done this for Zend Framework 1. I've done it for another number of other processes, and I'm starting a review of the Cobbler process. But here we've got a file at etc SELinux config. You can see what things are currently for reboot, whether it's enforcing where the policy is enforced, permissive where it just prints warnings, or disabled. And you have the targeted where it targets processes that are protected, as it says here, or the MLS where you start talking S0, S1, S2. And you can verify this is in the using SELinux section. 2.2. You can verify by get enforce or set enforce to set it, things of that amount. I'm not going to go into details. I suggest you read through the documentation, but I'm highlighting certain key items in here. Now, identifying SELinux denials. Tailing is one thing you can do. Another is AU search. And we'll go here. We'll copy this command here. Audit D has to be running on the system to get this information. The joys of a mouse button that sometimes double clicks on you. So here we see the denials for recent time. And here's our Wednesday, July 21st. This one up here was, or June 21st. This one was earlier today, and we're going back through. And then you can set here, and you can actually go through, and if you load policy core utils, Python utils, and such, you can set there and play around with the auditing and here's how it breaks down, the line here. And you can actually use these with audit to allow to create new policies. Now, one of the things that can also help you out is if you take a look and you install the SELinux policy docs, Cobbler has a web page for its SELinux. They'll always be of the form like Cobbler D SELinux, name D SELinux, Apache _ SELinux. And it'll talk about the entry points where the process sets the type for while it's running, the process type. And for Cobbler, that's Cobbler D _T. And here it talks about how you can make it permissive. If you want to remove permissive mode, instead of a -A, do a -D. But you'll find that some of these you need to go through and possibly change, such as whether or not you can network connect and whether or not you can use NFS and such. And the same thing is true over on Apache, where you have to enable network connections and things of that nature. And here's the file types. For example, cluster configuration files, run types. They'll be defined separate from Cobbler. And in fact, the security policies as a whole right now are defined in a SELinux policy package rather than in the Cobbler package. Most of these have been contributed after development teams didn't know how to go about adding their own policies. but we've got temp files for Cobbler. We've got files under varlib for Cobbler. Since Cobbler also manages DHCP, we have permissions associated with DHCP etc. And DNS mask, it can be managed, so we've got policies associated with those. The Kerberos 5 host R cache. Here's named, and notice we maintain the named zone files and some files underneath the etc directory. We've got NFST for files mounted from NFS, root T, rsync, since we can do rsyncs. We've got TFTP, and we've got information about sharing files and things of that nature. So going to the man page for the policy will help you learn about things. And in fact, we can set here, and we'll bring up the HTTPD one, where we've got the process types. We can connect to various things such as FTP, Memcache, enable an FTP server, and all these other permissions down here. So anytime you go to use a process, go through and read the Security Linux page for it, because it'll tell you whether or not you can do certain things. So with that said, we'll go back here to this, and we'll actually take a look at the process of setting up a process to use SELinux. And this is covered under section 8, where you write a little process, and you can sit there and you can say, create the policy here and such, and it creates a number of files. You've got type enforcement, TE files, an interface file, the IF file, the file context, that's the labels on the files, FC files. It'll create a template spec file for you and a setup script. And what do these look like? Well, let's take a look. I have installed over here the source code from GitHub. I've made a copy here, but if you follow it, it goes over to a Fedora SELinux. I'll post the link to it below. Policy. I've forked it since I'll be doing modifications to these. And I am in the top level directory. If we take a look, we've got man, doc, config, policy, and support as subdirectories. And if we go to policy, we'll see again Flask and support, and we got modules. If we go into modules, we've got a whole bunch of things here, but I know that what I'm interested in is under the contrib. And if we go ahead and enlarge this and do an ls, you see we got a whole bunch of them here. And And for example, we got Anaconda here. We got an antivirus. We got Apache. If we go over here, we've got IceCast, for example. INetD has its own deal, so it can actually fire off things to do its deal. FetchMail. And down here we've got Cobbler. So let's take a look at these. And we'll pop over so here's how we get the policies. We have a file path and the generated context. And so we can go through here and we can actually see that, for example, stuff under varlib cobbler has system user, object role, varlib cobbler type, and S0 security level. So you can see what directories it's allowed to access through its own local file context. Here's the interface file, and it says that for the Cobbler domain we have Cobbler D is accessible by Cobbler exec T, and has various other things such as execute the init scripts in the domain, read the config.drs, and you can do some reading in these individual files as well, because they're rather complex. That's the one disadvantage of SELinux, is it is complex, but it gives you a lot of control. So, for example, if we named's not in here because it's not part of the interface. But here's our tunables. And you can see the Cobbler used NFS. Type it right. Here we've got a few hooks to do name resolution. And that's the example of the Cobbler configs. Now, going through, you'll end up wanting to do a lot of digging to find out more details. But as I said, I'll leave links below to the manual page and or to the documentation, and leave references to certain man pages so that you can take a look at those and see what's going on. But with this information, you should be able to tell the difference between an SELinux policy issue and a normal permission issue, such as the WebSS file was having. So if you like this, leave comments below, subscribe, let people know about this, and I welcome any and all suggestions. I'm just getting started on creating these, so I don't have any fancy uh, graphics associated with it yet or anything like that. So enjoy yourselves and have a nice day.